Welcome back to the Daily Leetcode. Today we will be solving the longest common subsequence using a dynamic programming approach. And for these dynamic programming problems, it's really helpful to draw out the 2D array in order to see how the dynamic programming table is filled out from left to right, top to bottom, until we get to our solution, which will be the very last cell in the DP table. So each cell in this table represents the longest common subsequence between the substrings which end on that cell. Meaning, for example, if you were to take this cell, the answer would be the longest common subsequence between this substring here and this substring here. In which case you see that it would be A and A, which would be 1. Okay, so without further ado, let's start filling in the DP table. So the longest common subsequence between the base case or the empty string here would be 0. And similarly, the entire first row would be 0 because the first row represents the longest common subsequence between, for example, A and the empty string, and then between AB and the empty string, and AC and the empty string, etc. So making that whole entire row 0. And then along a similar symmetric reasoning, the entire first column is also 0 because that represents the longest substring between the empty string and A, between the empty string and AC, and then between the empty string and AE, which is all of length 0. Okay, so there are two different scenarios when we come across each cell and we're filling in the DP table. The first scenario is that the two characters at the cell match. So for example, A and A here match. And then in that case, we would take the cell to the diagonal. So looking at the two substrings without the matching letters, and we would add 1 to that because we just incremented the length of the common substring. And the other case is when the two characters at the indices don't match, such as A and B. In that case, we would take the maximum of the cell above and the cell to the left. So in this case, that would be 1. And the reason we do that is because we're saying that the longest common subsequence is still between these two subsequences right here, and the B doesn't really add on to anything. So we'll choose the maximum from the left. Okay, so we continue filling in the DP array in this manner. C1. Okay, so we see 2 C's here, so we take this one and we add. And then we can always check our answer by seeing if the longest common subsequence between this and this is in fact 2, which it is because we have AC here and we have A and C there. So just as a check, we could do that. Okay, so that would be 2, 2, and then this would be 1, 1, 2, 2, and then finally the 2 E's match, so take that, add 1, 3. And so our final answer would be the least common subsequence between the full 2 texts, which would be, in this case, 3. So now let's look at what the solution looks like in code. As always, I've commented a general structure, so if you would like, pause and try it out yourself. Okay, so first we initialize the DP array, which will be a 2D array. We'll call it grid. Okay, and the length will be text1.length plus 1 to account for the empty string base case. And the width will be the same, but for text2. Okay. Now we iterate through using a double for loop in order to fill in the DP array. And you'll notice that I started at index 1 simply because Java initiates the grid to be filled with all zeros, and we want to preserve the first row in that first column to be all zeros. So as we're filling in the DP table, there are two different scenarios. One where the last indices of the 2 strings match. So in that case, so if grid I-1 if text1 dot char I minus 1 is equal to text2 dot char minus 1, then grid of I j is equal to that diagonal plus 1. Else, we choose the maximum between the top, which is I minus 1, j, so the cell to the top, and to the cell to the left. So it would be I, j minus 1. And once we're done iterating through the entire DP array, we return grid of text1 dot length, text2 dot length, which will be the answer of the longest common subsequence of the entire text1 and text2. Okay, so let's submit. And there we go.